What do we know? There is a greenhouse carbon cycle, greenhouse effect. Nobody denies that. I guess I shouldn't say nobody. There are always going to be very strange people around that, but they are very little consequence. The CO2 levels are increasing, as evidenced by atmospheric monitoring all over. We're now at 385 parts per million, and a 20% increase in the 20th century, most by 1970 and up. The business as usual, if we keep doing the same thing, they'll double in the next 50 years. Humans are mostly responsible for the CO2 increase. Carbon dioxide is fossil fuel and cutting down trees and more farmland. The amount of CO2 far exceeds the natural range of the last 650,000 years. And remember though, we talked about CO2 was a lot higher back in primordial times. The overwhelming body of scientific evidence has been that there is an average increase in the last 100 years, and this is not uniform. Arctic is a lot warmer. The parts of the Antarctic and South Pacific are cooler. Okay. The Intergovernmental Panel on Climate Change, it's founded by the UN in 1988. It doesn't do its own research. It takes others and puts it together and synthesizes it and does another peer review. It's done 4 of these. It takes a long time to put all this information together. And look at this. 130 countries, 450 lead authors, 800 contributing, and then here's the peer review. It was kind of cool because they were on a blog by a guy that I admire. Said, why don't you put the peer reviews for public viewing? And they were resistant to begin with, and he got them to do it. And I looked at them, and it is reams and reams and reams and reams and reams of paper. And I simply looked at the introduction. The work of the IPCC has not been without controversy nor criticism, including some of the experts that they invited to do reports and to serve on its panels. But overall, it is extremely respected and has even won a Nobel Peace Prize. What did they say in the last report? This is from the spring of 2007. Okay, warming is unequivocal, 1.3 degrees Fahrenheit. Now you must remember too that they have upped that amount since their last modeling. Okay, so the models are continually improved, but there is uncertainty involved in this. Okay, most of the observed increase in globally average temperature since the mid-20th century is, here we go. This is what really got people going. Very likely, and they're saying that they're sure up to 90%, they're 90% sure. And when they do this, this is a real number. Sometimes I'll glibly say, I'm 90% sure that I didn't put the milk away. But they mean they have ways of determining this. It's not just a glib statement. And this is due, that the rise in temperature is due to man-made. That's anthropogenic. Man-made and woman-made greenhouse gas concentrations. Okay. Dry regions are getting drier, wet regions are getting wetter. This is why we call it climate change. Not just temperature, also known as climate extremes. This concerns people a great deal. Water supplies stored at low latitude glaciers, that means near the equator, and snow cover being reduced. Melting of the polar ice glaciers presents real dangers. We are getting more snow though in the Antarctic. Spring events such as the unfolding of leaves, the laying of eggs, and migrations are happening earlier. And the ranges of plants and animal species are shifting. The fear is that they will not be able to adapt. Are they adaptable in time to save themselves? Lots and lots of information from the IPCC 2007 report. This is cold nights, cold days, and we're looking at differences in overall behavior. We're looking at changes in precipitation. There's plus and minuses there. You'll notice the United States has more. Where they can least handle it is getting less. Okay. Anything interesting here? You'll know that they say 1.3 degrees Fahrenheit. That doesn't seem like a lot. But up in the Arctic, they're seeing a lot higher. And for us, here we are. Oh, golly. They are seeing fewer cold nights and more cold days. I don't know. But we are staying pretty stable here, and then warm days is going down a little bit. Okay. So there we have here, and boy, I don't know. When I'm doing this right now, they are having horrible, horrible fires in Australia. And it's because of a 20-year drought. Oh my gosh. So we have this and we have that, and I'm wondering how much of each these are showing. Annual trends, this is here, but when we look, there's a great deal of difference from 76. The 70s is when things started really happening. And you can see that this area's gotten a lot hotter. But look, there still is some blue saying that these guys have gotten cooler. We have gotten a little warmer overall. NASA study says most of the Arctic warmed significantly over the last decade, with the biggest temperature increases over North America. So here we are, North America down here. And this is the ice cap. It changes depending upon the time of year. And they're figuring that they're losing about 9% overall per decade, and they're thinking it's going to all be melted by 2040. This is a good thing for people who wish to bring their boats across here for shipping lanes. They are pretty excited, and there's a big fight now with Russia, Greenland, and Canada, and us to claim this previously unwanted area. And it also says as the ocean's warm and thin, ice thins, more solar energy that used to be, like this, the solar energy would be repelled or reflected back from, how white reflects and black absorbs? Well, it's absorbed by the oceans, reflected by the ice, so we call this positive feedback, so it's going to further enhance melting. Okay. And another weird thing is, how about the Gulf Stream across the Atlantic? If it starts failing due to changes in the temperature of the water, this would mean that England would get colder. I don't know if you've ever been to England, but it has palm trees on the west coast. And that is because of this beautiful Gulf Stream bringing warm water up to a very high latitude area. So England is at about the same latitude as, I think Upper Canada. Okay, here is Arctic ice. See how it leaves in September, the summer. And then here it is at max, and 208. And they've tried to put a purple line to show you how it is getting even less in the winter. Nope, there's more in the winter. There's more ice in the winter, but less in the summer. And this is where my knowledge I have trouble, because is there more snow because it's warmer? When it gets really, really cold, it doesn't snow, and there's less, because there's less moisture in the air? That is a nice question to ask. Okay, all right. What they're trying to show you is that the summer minimums are getting less and less. Okay, summer Arctic ice, again, this is another way of putting it. It's going down. Oh my, this looks like an anomaly. And sea level goes up, the water goes someplace. Remember, most of this ice is above sea level, so when it melts, it will raise the level of the water. Now this is called the Antarctic controversy, because the blue means colder. And you can see a large proportion here has gotten colder. And some observations, like this area here, this is getting warmer. Big ice is calving off big ice. Uh, Large ice flows are going into the ocean, and there still is questions why this part is warming. But overall, the amount of snow and ice and glaciers is going down. Patagonia is the South America, the tip of South America. And the sad part is that a lot of people get their water from the slow melting snow and ice and glaciers. So as glaciers disappear, the water supply, as the glaciers go down, the water supply from rivers goes down. These guys don't have wells. They pull out from rivers and streams. And we saw it when we went to Peru that the river levels were lowest they'd ever been historically. And in fact, Los Angeles is building a huge pipeline to bring in water because they're assuming Colorado was not going to be fed by enough ice melt. Kilimanjaro should be gone in very soon. 90% of it's left since about 100 years ago. And here's Lonnie Thompson. Lonnie Thompson is an awesome guy who is a professor at Ohio State. He's in charge. He's a senior research scientist at the Byrd Polar Research Center, and we have the largest repository of ice cores. OSU on West Campus largest repository of ice cores. Historical, deep. And what's neat is they'll open them up and they'll find out what gases are in the air pockets down there. They can figure it out. Oh my gosh, 750,000 years old of ice. Oh my goodness, so fabulous. And he has been on the cover of Rolling Stone. That's an old song that you probably don't know. And just a fabulous guy. And he is telling us that most of the world's temperate glaciers, again, this is close to the, this is away from the poles, will be disappearing in the next century. They are like the canaries in the mines. They signal great danger. Here is all water, and here in 78, not very long in terms of geological events, it was all ice. Okay. Now here's interesting. Now they talk about the hurricanes. They said, oh, see, we knew that Katrina was coming because of global warming, but they've had two of the quietest hurricane years since then. So there still is a bunch of stuff to put into their modeling schemes. But forcing is all the effects that they put in, and these are astronomically complicated. But in a nutshell, if you just simply take natural forcings like the Milankovitch cycle of the sun and volcanoes erupting and La Niñas, La Niñas, we have the observed versus model. Here's our model, and here's what's been observed. Not a great correlation. If you just take anthropogenic, man-made stuff, it's a better fit, but not perfect. If you do all forcings, a very good fit. And this is historical. Right? This is not proposing for the back into the future. This is historical fit. Okay, great. Okay. And here we do it for all over the globe. This is using only natural as the blue. So this is blue as the natural. And using all forces, natural and anthropogenic, is a very nice fit. Okay. But we must not gloss over uncertainties. Let me say it's important to appreciate the predictions made by previous climatology models are correctly predicting many observations. These models continue to produce with increasing precision many of the past changes all the way back to the Ice Age. They get better and better and better. But we have to be cautious. There are plenty of scientists who oversell the predictive capability. Predictive, that means looking into the future. And they provide a legitimate basis for criticism and actually, I think, create obstacles on action to climate change. And I keep beating the drum, but please understand, all scientific studies are going to have uncertainties, and the planet's environment is a hugely complicated structure. It's the most complicated structure that people have tried to scientifically interpret. And any range of important uncertainties coming from the scientific scenarios is instantly construed, though, as lack of confidence. Politicos, the public, everybody says if you show any kind of questioning nature or discuss the uncertainties, they jump all over you. So I can kind of understand why often the scientists come up full of piss and vinegar and say they're absolutely sure. Okay, they make headlines, but they're frequently invalid. For example, the rate of sea level has slowed, and hurricane activity, like I say, were the quietest years in 30 years in 2006 and 2007. And 11 of the past 12 years, they say, has been the warmest since records, but only by hundredths of a degree. And there are a lot of people who argue that the math calculations show the 30s were the warmest decades. And again, this is by hundredths or thousands of degrees. And also, I kind of wonder how valid they believe their numbers are for many of the places that were pretty rough and tumble back in the 30s. Beijing or some places in South America and Africa, even in what so-called developed areas. Okay, so where are we? And this will be the last slide. Combatants in the debate congregate around extremes. And for all the millions of hours, we don't know. And these are quotes from climatologists. And the problem is that they say is it could be, they only say that all the studies say it's likely to be bad, and it might be an appalling catastrophe. Therefore, it is impossible to rule out the bad catastrophe, so we need to act. Because we cannot. Because it is maybe mild or it may be catastrophic, but we don't know. The debate is I must say the debate is extremely important. It's the foundation of scientific inquiry. This is why I love science. You very rarely turn on Fox or CNN and have one of those talking heads say, I was wrong. No way. They just blah, 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 blah. But scientists you often hear say, wow, that really makes sense what you say. I think I'll go and try that. And I was wrong. Today, this often occurs quickly and openly on the internet, in blogs and newsletters. But if debate leads to inaction, then we're all in trouble.